Welcome to Talk Tensors, your one-stop shop for all things machine learning research. We love diving into the latest and greatest advancements in AI, and today is no exception. We're going to be tackling a paper that caught our eye. It addresses a pretty critical and often overlooked aspect of AI agents, making sure the tools they use actually work as intended.
Yeah, it's an area that's absolutely ripe for attention. As we delegate more and more tasks to these AI agents, we need to be confident that they can interact with their tools reliably and accurately.
Exactly. The paper we're dissecting today is called ToolFuzz, Automated Agent Tool Testing. It comes to us from the brilliant minds of Ivan Milov, Bullinovich, Milliambeater, and Martin Vettaschef over at ETH SIRC. Now, why is this paper so important? Well, think about it. We're increasingly relying on AI agents to navigate the real world for us. Everything from scheduling appointments to managing our finances. But what happens when the tools they use are riddled with errors due to poorly written documentation? Chaos, that's what.
Oh, yeah. Just imagine an AI travel agent booking you a flight to the wrong city, or a financial agent accidentally transferring funds to the wrong account, all because the tool's documentation was unclear or inaccurate. This paper highlights the urgent need to thoroughly test these tools before unleashing them in the wild.
Okay, so let's unpack what the ToolFuzz paper is all about. The researchers have identified two major categories of tool failures that can really trip up these AI agents. First up, we have runtime tool failures, where the agent tries to use a tool with inputs that simply don't work.
Yeah.
Like trying to enter your birthday as a phone number.
Right.
It's just not going to work, is it?
Nope. The other category is correctness failures, where the tool might run without crashing, but it produces the wrong result because the documentation wasn't specific enough. It's like a recipe that calls for a pinch of salt when it really means a tablespoon. You end up with a very salty surprise.
And not the good kind of surprise.
Okay.
So how does ToolFuzz come to the rescue in these scenarios?
Well, the researchers cleverly combine, traditional software testing techniques with the power of LLMs. One approach they use is called Taint fuzzing. This involves deliberately feeding the tool a bunch of carefully crafted bad inputs, things designed to trigger errors.
So they're basically trying to break the tool on purpose. Sort of like those mischievous quality assurance testers who try to crash websites by entering all sorts of crazy data into the forms.
That's a great analogy. And when they find an input that breaks the tool, they use an LLM to generate realistic user queries that would likely trigger that same error in an actual agent environment. This way, they can see how these errors might manifest in the real world.
That's really clever. So it's not just about finding errors in a vacuum. It's about understanding how those errors might occur in a real-world setting with a real human user interacting with the AI agent. But what about those sneaky correctness failures, the ones where the tool runs but produces the wrong result? How did they catch those?
For those, they use something called prompt sets. This involves generating multiple ways of asking the same question. Different prompts that should, in theory, lead the agent to use the tool in the same way.
So if the agent gives different answers to prompts that should mean the same thing, that's a big red flag that the tool's documentation is wonky, right?
Exactly. And to be extra sure they're not missing any errors, they use another LLM acting as an oracle to check the agent's answers against what a human expert would expect. If the oracle disagrees with the agent, that's another sign that something's amiss.
So it's like having a double-check system in place to make sure those AI agents aren't getting fooled by bad instructions. Now, to put all this to the test, they didn't rely on existing benchmarks. They created two new ones of their own. What can you tell us about those?
They're really quite ingenious. The researchers understood that most existing benchmarks for AI agents, focused on the agent's overall reasoning ability, not specifically on its ability to use tools accurately. So they created a file management benchmark, which involves tasks like finding files, copying them, moving them around. They also created a GitHub benchmark, which tests the agent's ability to interact with GitHub, like searching for repositories, finding specific files within a repository, and so on.
So tasks that really rely on precise tool usage and clear documentation, not just general cleverness on the part of the agent.
Precisely. And what they found is that when they used ToolFuzz to improve the tool documentation, the agent's success rate on these benchmarks skyrocketed. Especially on those file management tasks, the improvement was dramatic.
That's remarkable. So it seems like ToolFuzz is doing exactly what it set out to do. It's identifying those sneaky errors in tool documentation that could trip up AI agents. And it's providing developers with the insights they need to fix those errors and make their tools more robust.
And it's not just about making AI agents more reliable. It's about making software better for everyone. Clear, concise, and accurate documentation is crucial for any tool, whether it's being used by a human or an AI.
Okay, we've got a good grasp of what ToolFuzz is and why it's important. But to really appreciate the significance of this research, I think it's helpful to understand the historical context. What led up to this research? Were there any earlier attempts to tackle this problem of AI agents misusing tools?
Well, the field of AI agents is relatively young, but it's evolved, rapidly. Early agent systems were quite simplistic, often relying on pre-programmed rules and decision trees. Think of those early chatbots that could only respond to a limited set of predefined inputs.
Right, those chatbots that would get totally thrown off if you asked them anything outside their narrow script. Not exactly the AI companions of our sci-fi dreams.
Exactly. But as natural language processing took, leaps and bounds with the advent of transformers and large language models, these AI agents became much more capable. They could handle more complex tasks, plan multi-step actions, and even generate creative text formats, like poems or code.
That's where things get really interesting. So when did researchers start to realize that these super smart agents could still trip over poorly documented tools? Was it a sudden aha moment or a gradual realization?
It was more of a gradual dawning as researchers started to deploy these agents in more complex and real-world scenarios. Remember, early research often focused on toy problems or highly controlled environments.
Makes sense. You need to learn to walk before you can run a marathon.
Yeah.
Or in this case, manage someone's entire financial portfolio.
Right. As AI agents were tasked with things like booking travel, interacting with websites, or even controlling robots, it became clear that they were highly sensitive to the quality of the information they were given about their tools.
So a brilliant agent could still book you a flight to the wrong city if the tool's documentation didn't clearly specify how to enter the destination.
Exactly. And the problem became even more pronounced as researchers started to explore tool augmentation, the idea of giving agents access to a wide array of tools, each with its own quirks and documentation style.
So it's not just one recipe with a pinch of salt that could go wrong. It's an entire kitchen full of potentially misleading instructions.
A great analogy, though potentially disastrous in practice. And as the number of tools increased, so did the potential for miscommunication and errors.
It's like that classic game of telephone where a message gets distorted as it's passed from person to person.
Yeah.
Except in this case, it's an AI agent trying to decipher instructions that might be ambiguous or incomplete.
Yeah, I see what you mean. And with real-world consequences. Imagine an AI assistant trying to coordinate multiple tools to plan your day, booking appointments, arranging transportation, managing your finances. If even one of those tools misbehaves because of a documentation glitch, the whole system could fall apart.
Calendars and shambles, funds wired to the wrong account. That's AI assistant horror story material right there.
Indeed, and that's why the ToolFuzz paper is so significant. It's one of the first to explicitly recognize the importance of rigorous tool testing in the development of reliable AI agents. It's a wake-up call to the field, urging us to move beyond simply building smarter agents and focus on building trustworthy agents. Agents that can interact with their tools in a predictable and robust way.
Okay, we've got the stage set. We understand the problem. We've explored the historical context, and we've peeked into the inner workings of ToolFuzz. Now let's get down to the nitty-gritty and see this thing in action. What were some of the most eye-opening case studies the researchers presented?
One example that immediately comes to mind involves a tool designed to interact with OpenStreetMap. This tool allows agents to get directions and calculate distances between locations.
That sounds super useful. I could definitely use an AI agent to plan my next road trip.
In theory, yes. But the researchers discovered that the tool's documentation was a bit lacking in detail. Specifically, it didn't explicitly state that users needed to include the country when specifying a city.
Oh, I see where this is going. So if I asked for the distance between Paris and Lyon, the agent might get confused because there's a Paris in Texas and a Lyon in Michigan.
Precisely. And that's exactly what happened. The agent, following the tool's poorly worded instructions, calculated the distance between those two American cities, not the ones in France.
Wow, that's a pretty major miscalculation. I can see how that could lead to some serious travel headaches. So how did ToolFuzz uncover this hidden flaw in the documentation?
In this case, it was the correctness failure detection mechanism at work. ToolFuzz generated multiple prompts that were semantically similar, but differed in how they referred to the cities.
So some prompts might have said Paris, France, and Lyon, France, while others might have just said Paris and Lyon.
Exactly. And when it observed that the agent returned wildly different distances based on these seemingly minor variations in phrasing, ToolFuzz correctly flagged the tool's documentation as a potential source of error.
It's amazing how such a small detail can make such a big difference. It really highlights the need for a level of precision in AI agent tool documentation that we might not typically demand from software intended for human use.
That's a great point. Humans have a knack for filling in the gaps, making inferences, and even spotting inconsistencies. But AI agents, not so much. They tend to take instructions very literally.
And we all know what happens when you assume. So ToolFuzz helps to eliminate those assumptions and ensures that the instructions are crystal clear for those AI agents.
Exactly. And that brings us to another fascinating case study, the terminal tool. This tool, as you might guess, allows agents to execute shell commands. Think of it as giving an AI agent the power to interact directly with a computer's operating system.
That sounds incredibly powerful, but also incredibly dangerous if not handled carefully.
You're absolutely right. The researchers found that the initial documentation for this terminal tool was so vague that it was practically an invitation for disaster.
So like giving a toddler the keys to a bulldozer.
A colorful analogy. The documentation, as it was written, didn't clearly specify how to format commands, how to navigate the file system, or even which commands were safe to execute. As a result, the agent kept trying to access invalid file paths, executing commands that made no sense, and generally wreaking havoc.
Oh no, digital mayhem. It makes you wonder how many times this has happened in real-world scenarios without anyone realizing that the root cause was poorly written documentation.
It's a sobering thought, and it's precisely why ToolFuzz is so valuable. In its runtime failure detection mode, it was able to quickly reveal the gaping holes in the documentation for the tool.
So it's not just about finding errors. It's about understanding why those errors occur and how to prevent them in the future. That's where the real value of ToolFuzz lies.
I couldn't agree more. And by providing this detailed analysis of the errors, ToolFuzz enabled the researchers to significantly improve the documentation for the terminal tool, making it far more robust and reliable.
That's reassuring. So we've gone from a toddler with a bulldozer to a responsible operator with a clearly marked safety manual. Now, I'm curious to hear more about how ToolFuzz actually works under the hood. Can you give us a bit more technical insight into the algorithms and methodologies that make it tick?
Of course. Let's start by revisiting those two key error detection techniques: taint fuzzing for runtime failures and prompt sets for correctness failures.
Perfect. Let's break those down one by one. Starting with taint fuzzing. It sounds a bit like a biological experiment gone wrong.
No hazardous materials involved here, I assure you. But the analogy is apt. In traditional software testing, fuzzing involves throwing a bunch of random or semi-random inputs at a program and seeing if it breaks.
So it's like a stress test for code, seeing if it can handle the unexpected.
Exactly. But when it comes to AI agents, simple random inputs won't cut it. Remember, these agents are designed to interact with tools that expect structured data, natural language commands, or even specific formats.
Right. You can't just feed an AI travel agent a string of random characters and expect it to book you a flight to Hawaii.
Precisely. And that's where the taint part of taint fuzzing comes in. The researchers cleverly combine traditional fuzzing with an understanding of the tool's expected input format.
So they're not just throwing random data at it. They're crafting inputs that are deliberately malformed, but still conform to the tool's basic expectations.
That's right. Think of it as a targeted attack, designed to exploit specific vulnerabilities in the tool's logic. They use a technique called taint analysis to trace how inputs flow through the tool's code, identifying points where a slightly altered input could trigger an error.
So they're essentially reverse engineering the tool to figure out how to break it.
In a way, yes. But it's not about breaking the tool for the sake of breaking it. It's about understanding its limitations, its points of fragility, so that we can make it more robust.
It's like a martial arts master who can pinpoint their opponent's weak spots, not to exploit them, but to help them strengthen their defense.
That's an interesting way to think about it. And just as a martial arts master can train their student to withstand different attacks, ToolFuzz can help developers identify and fix the vulnerabilities in their tools, making them more resilient to the unexpected inputs that an AI agent might throw at them.
And once ToolFuzz has identified these potential breaking points, these inputs that trigger errors, what happens next? Do they just present a long list of errors to the developers and say, good luck fixing those?
That wouldn't be very helpful, would it? No, ToolFuzz goes a step further. It uses an LLM to translate those bad inputs, those error-triggering inputs, into realistic user queries.
So it takes those deliberately malformed inputs and turns them into something that a real human user might actually say to an AI agent.
Exactly. And this is where the power of LLMs really shines. They can take a technically precise but rather abstract error condition and express it in a way that's understandable and relevant to the context of the tool's intended use.
So instead of just saying input exceeds maximum length, ToolFuzz might generate a user query like, "Hey, AI agent, can you summarize the entire text of War and Peace for me?"
That's a great example. It's a perfectly plausible request from a human user, but one that could easily overwhelm a summarization tool that hasn't been properly tested for handling such lengthy inputs. And by presenting these realistic user queries, ToolFuzz helps developers understand not just that their tool can fail, but how it might fail in the real world.
It's the difference between knowing that a bridge is weak and knowing that it's likely to collapse if a fully loaded truck drives over it. One is an abstract concept. The other is a concrete scenario with real-world consequences.
Precisely. And by making these potential failures more concrete, more relatable, ToolFuzz empowers developers to fix those vulnerabilities before they lead to real-world harm.
Okay, that's taint fuzzing demystified. Now let's tackle the other technique, prompt sets. You mentioned earlier that this involves generating multiple ways of asking the same question.
Yes. And it's a clever way to uncover those subtle correctness failures where the tool might run without crashing, but still produce the wrong result.
So it's like asking a chef for their recipe for apple pie, but phrasing the question slightly differently each time.
Precisely. You might ask, what are the ingredients for your famous apple pie? Or, can you share the steps for making your delicious apple pie? Or even, how do you bake an apple pie from scratch?
And if the chef gives you a wildly different set of instructions each time, you might start to suspect that their recipe isn't as well defined as they claim.
A culinary analogy that perfectly captures the essence of prompt sets. ToolFuzz does something similar with AI agent tools. It generates multiple prompts that should, in theory, lead the agent to use the tool in the same way.
So if I'm testing a tool that searches for research papers, I might generate prompts like, "Find me papers about climate change, show me the latest research on global warming," or "What are the most cited publications on the impact of human activity on the environment?"
Exactly. And if the agent using this research paper tool returns vastly different sets of results based on these subtle variations in phrasing, that's a strong indication that something's fishy.
Either the tool's documentation is ambiguous, allowing for multiple interpretations, or the tool itself is inconsistent in how it processes queries.
Precisely. And ToolFuzz, like a meticulous editor, flags these inconsistencies, alerting developers to the need for greater clarity and precision.
Now, you mentioned earlier that ToolFuzz uses an LLM oracle to double-check the agent's answers. What role does this oracle play in the prompt set technique?
Ah, the oracle. Our wise and impartial judge in the realm of automated testing. Remember, with prompt sets, we're looking for subtle errors, cases where the tool might produce a result that's technically valid, but still incorrect in the context of the user's intent.
So it's not just about checking if the tool crashes or returns an error message. It's about checking if the tool is truly understanding and responding to the user's needs.
Exactly. And that's where the oracle comes in. It's an LLM that's been trained on a vast data set of human knowledge and reasoning. We can think of it as the embodiment of expert knowledge in this context.
So it's like having a panel of human experts on hand to evaluate the AI agent's performance.
That's a good way to put it. And just as a panel of experts would scrutinize the agent's outputs, comparing them to their own knowledge and expectations, so too does the oracle.
So if I'm testing that research paper tool, and the agent returns a list of papers that seem tangentially related to climate change, but not quite on target, the oracle would flag those as potentially incorrect.
Precisely. The oracle would analyze the agent's outputs, compare them to its own vast knowledge base, and highlight any discrepancies or inconsistencies. It's like having a second pair of eyes, or rather a second brain, to ensure that the agent's outputs are truly accurate and relevant.
It's like a safety net, catching those subtle errors that might otherwise slip through the cracks. Now, this oracle sounds incredibly powerful, but how do the researchers ensure that it's not biased or influenced by the specific tool being tested?
That's a crucial consideration. We wouldn't want our oracle to be swayed by the very tool it's supposed to be evaluating. So The researchers employ several techniques to ensure the oracle's impartiality. Firstly, they train the oracle on a massive data set that's independent of the tool's documentation or code.
So it has its own vast knowledge base to draw on, not just the information provided by the tool.
Exactly. It's like sending a judge to law school before they preside over a case, ensuring they have a solid foundation of legal principles to work with.
That makes a lot of sense. So the oracle has its own knowledge and is trained separately from the tool being tested. Are there any other safeguards in place to ensure its objectivity?
Yes, indeed. They also use a technique called prompt engineering to carefully craft the prompts that are given to the oracle. They want to make sure that the prompts are neutral and don't lead the oracle to any particular conclusion.
So they're not asking leading questions or giving the oracle any hints about what they expect the agent to do.
Precisely. It's like instructing a jury to base their verdict solely on the evidence presented, not on any preconceived notions or biases.
That makes perfect sense. So by combining a well-trained LLM with carefully crafted prompts, they've created an oracle that can provide an objective assessment of the agent's performance. It's like having a trusted advisor who always has your best interests at heart, making sure the AI agent stays on the right track.
That's a nice way to think about it. And this trusted advisor, this LLM oracle, plays a crucial role in ensuring that AI agents are using their tools not just effectively, but also ethically and responsibly.
Welcome back to Talk Tensors. Before the break, we were talking about the potential of expanding ToolFuzz to tackle more complex multi-tool systems. But let's get back to the paper at hand. I'm really curious to dive into some of the specific case studies the researchers presented. I'm sure our listeners are eager to hear about the surprising errors that ToolFuzz uncovered.
Oh, I think you'll find these cases quite illuminating. They really showcase how even seemingly simple tools can harbor, subtle documentation flaws that could lead to unexpected and sometimes even, harmful outcomes.
Okay, I'm ready for some AI agent detective work. What's one of the tools that really surprised you in terms of the errors ToolFuzz uncovered?
Well, the PubMed tool definitely stands out. As you know, PubMed is this vast database of biomedical literature. It's an essential resource for anyone involved in medical research.
Yeah, if I need to research a medical topic, PubMed is my go-to. It's an incredible resource, but it can also be a bit daunting to navigate. So I can see how an AI agent could be incredibly helpful in sifting through that mountain of information.
Exactly. And there are tools designed to let AI agents interact with PubMed to search for relevant papers, extract key findings, and so on. But the researchers discovered that even these specialized tools can be tripped up by poorly written documentation.
Okay, now I'm intrigued. What kind of errors did ToolFuzz find in the PubMed tool? Was it struggling to understand complex medical terminology or something like that?
It was actually something far more subtle but equally problematic. ToolFuzz discovered that the tool's documentation didn't adequately explain how to search for papers published within specific date ranges.
So if I asked the agent to find papers on, say, the effectiveness of a certain cancer treatment published between 2015 and 2020, it might return papers outside that time frame.
Precisely. The tool might just ignore the date range entirely, or it might misinterpret the query. It could end up returning papers published in 2015 or 2020 rather than between those years.
That's a pretty major oversight. It could lead researchers to miss critical studies or draw inaccurate conclusions based on outdated information.
Exactly. And this highlights a crucial challenge in AI agent tool development. It's not just about providing enough information. It's about providing the right information in the right way.
It's not just about quantity, it's about quality. The instructions need to be clear, concise, and unambiguous. There's no room for interpretation or guesswork when you're dealing with AI agents.
Absolutely. And ToolFuzz, with its meticulous attention to detail, was able to pinpoint this flaw in the PubMed tool's documentation. By generating a series of queries that varied the date ranges, it observed that the agent was consistently returning incorrect results.
That's a great example of how ToolFuzz can really help developers catch those subtle errors that might otherwise slip through the cracks.
I agree. And once ToolFuzz identified this problem with the PubMed tool, it was relatively straightforward to fix.
So they didn't have to rewrite the entire documentation from scratch.
No, thankfully not. ToolFuzz not only identifies errors, but also provides valuable insights into the root causes of those errors. In this case, it highlighted the need for more specific instructions on how to format date range queries. It also revealed the importance of explicitly stating that certain search fields, like publication date, require a specific syntax.
So instead of just saying you can search by publication date, the documentation now needs to say something like, to search by publication date, use the following format. and then provide a clear example.
Exactly. By providing that extra guidance, the researchers were able to significantly improve the accuracy and reliability of the PubMed tool.
That's a great example of how ToolFuzz can be both a diagnostic and a prescriptive tool. It's like having an AI-powered editor for tool documentation.
I like that analogy, and just as a good editor helps us write more clearly and effectively, ToolFuzz helps developers create tool documentation that is precise, unambiguous, and AI agent-friendly.
This PubMed case study is a great illustration of how ToolFuzz can uncover these subtle but significant documentation errors. What other case studies from the paper really stood out to you?
Well, there's another one involving the OpenStreetMap directions tool. This tool is designed to find routes between locations and calculate distances, similar to what you'd use a GPS navigation system for.
Yeah, that makes sense. I could definitely see an AI agent using this tool to plan my commute, find the fastest route to the store, or even guide me on a cross-country road trip.
Right. But the researchers discovered that this seemingly straightforward tool was full of potential pitfalls. And these pitfalls all stem from ambiguities in the tool's documentation.
Interesting. What kind of ambiguities are we talking about here?
Well, it turned out that the documentation didn't explicitly state that users needed to specify the country when entering a city name.
Oh, I see the problem. So if I ask the agent to find a route from, say, Paris to Lyon, it might get confused because there's a Paris in Texas and a Lyon in Michigan.
Exactly, and that's precisely what happened. The agent, following the tool's instructions, literally calculated a route between those two American cities, not the ones in France.
Wow, that's quite a detour. It really highlights the importance of being crystal clear in your instructions, especially when you're dealing with AI agents.
Absolutely. And again, ToolFuzz was instrumental in uncovering this flaw. By generating prompts that included the country and prompts that didn't, it was able to pinpoint the source of the confusion.
It's fascinating how ToolFuzz can reveal these hidden assumptions that we often don't even realize we're making.
And the fix, as with the PubMed tool, was relatively simple. Just add a sentence to the documentation stating that users need to specify the country when entering city names.
It's amazing how such a small tweak can make such a big difference in the reliability of an AI agent.
I agree. It really underscores the importance of clear and concise communication in software development, especially when it comes to tools that will be used by AI agents.
These case studies have been really insightful. They highlight the importance of rigorous tool testing and documentation in the world of AI agents. As AI agents become more integrated into our lives, the consequences of errors become more significant. So tools like ToolFuzz are essential for ensuring that these agents operate safely and reliably.
I completely agree. The ToolFuzz paper is a valuable contribution to the field. It's a call to action for developers to prioritize not just the intelligence of their AI agents, but also their trustworthiness.
Well said. And on that note, I think it's time to wrap up this deep dive into the world of AI agent tool testing. It's been a fascinating exploration of a topic that's becoming increasingly important as AI agents play a larger role in our lives.
I've enjoyed our conversation. I hope our listeners have found it informative as well.
I'm sure they have. Thanks for joining us on Talk Tensors. If you want to learn more about ToolFuzz, be sure to check out the show notes for links to the paper and other resources. And until next time, keep those machine learning minds engaged.